My name is Petra Stoltenkamp. I work for Wärtsilä. I'm a product performance manager for the product group thrusters.
Excellent, thank you. In your presentation, you gave a very interesting description of how you use CFD and other modelling when it comes to thruster development, configuration, etc. Can you give us more details of how this happens and what the results are?
Yeah, we've been working already within Wärtsilä for over 15 years using CFD calculation as a performance prediction for all kinds of propulsors. And basically what we have seen, it's before that time, they used to do a model test to validate this. Although it was known that model tests needed to be corrected for friction effects. And these corrections, they are rather good for open propellers, but for thrusters, they are not so correct. So at a certain point, we decided, okay, in CFD, we can do the calculations full scale and don't need the correction. One of the difficulties, of course, in full scale, that is difficult to measure, so validate. So that we tried over the years to have as good as validation, also working together with other research groups and getting the best information. And this way, we started to develop our products, especially with thrusters, where it's a combination of the propeller, the thruster, the housing, and looking at all different kind of scenarios to really understand the performance of the thruster.
You talked about the tilt of thrusters. What has Wärtsilä found to be the optimal tilt and why?
There was already some research of tilted thrusters, and that found that the optimum angle was around 8 to 9 degrees. And we did similar research ourselves, and we found indeed that it worked. The key is that you don't want to have a too high angle, because that means basically that your thrust is not directed anymore in the direction you want to compensate the force for. So you need to avoid that. And then also, if it's still not enough, you still have this interaction with the hull, which you want to avoid. So it was found that that was exactly the right compromise to have this around 8 degrees angle.
And what are the main marine applications for the thruster at this 8-degree tilt?
Basically, it's for a thruster that is underneath a hull, for example, retractable, or a thruster that is mainly in DP. It is mainly used to avoid thruster-hull interaction. So if you're looking at transit, it might be less beneficial, because there you want the forward push, and interaction is not always a problem. So it is mainly used for DP thrusters to avoid interaction. For example, also for semi-sub type of vessels where you have two pontoons, you want to avoid that your one thruster hits the other pontoon, and therefore it's also very good solution.
You also mentioned a digital tool that Wärtsilä has developed. Can you elaborate more?
Yeah, Wärtsilä has developed a tool called OptiDP, which is basically a static DP tool. It's verified by DNV, and it can do level 1, level 2 site calculations, so everything's static. But the only difference is that we take into account the 360-degree interaction of the thruster. That means that we look at where is the thruster placed, what is the interaction in all directions, where are all the forbidden zones, and yeah, by taking that into account, you can also make better decisions to avoid this.
And what's the future in development of Wärtsilä thrusters and these digital tools?
Well, our goal is to make sure that our thrusters are aligned with working good operational profile. So it should be a good product, but it also should complement what ship owners want to have on their vessel. So the future developments will be in that direction to make sure that these products are working in all different kind of cases. Additionally, we are looking We developed these tilted thrusters around 10 years ago, when oil and gas was a big driver of the market. And we developed all these thrusters, tilted thrusters, mainly for the oil and gas market, for the large vessels and the water mountable thrusters. Now, in recent years, we see that there is more question for smaller size thrusters. So we are developing also this. We have developed already some of the smaller thrusters, and we continue to develop also the smaller thruster sizes as well.